See, this one got current. This one got current. So it's electromagnet. And it will produce force. So use left hands. This one use left hands. Flaming left hands. I follow the question. First, draw the magnetic field like this. This is your M magnetic field. Force. Use your left hands to determine. This one current, current into paper. Okay, then found the force. Where is the direction of force? Will be down. I try, can able to get or not. Force is downward. So B, if the current reverse, what happened to your direction of force also reverse. You may write reverse enough. You don't need write upward downwards. Because if you A wrong, you B still can correct. Reverse ma. All of them can be correct. So next, magnetic field. Draw the magnetic field. For straight wire, it will be circle. And third circle need to far away because become weaker. Be careful, the third one, the distance increase. Okay, then what is next? You need to find the direction of magnetic field. It will be clockwise. Right hand, grip through. Change, current increase, magnetic field becomes stronger. Okay, then D, D is very special question. Why special? Got magnetic field vertical outwards. And then a small magnet put inside. So much smaller than the magnetic field. Then you see the magnetic field is like this. So north go to south. So actually question asks a small magnet inside a big magnet. What happened to the small magnet? So the south will move downwards. South pole of small magnet move downward. Attract to the north. If you're confused, you can draw the diagram better. So this one is single wire, carry current, and tell you into the patch, current into the patch. So use your right hand grip through. Right hand grip through. Your thumb is current into the paper. Others is in clockwise. See the question? An arrow for each. So got 4 circles, 4 arrow. And then tell you why the circle keep increase the distance. Magnetic field become weaker. Because they are weaker and weaker when you move away from the wire. This circuit already simplified. So you see when it's door lock and door frame is empty. Where is door frame? And then here, door frame. Slot is surrounding. Iron, you still use iron. Because iron will be demagnetized easily. Show you when it lock, how it lock. So when the S is closed, question says the solenoid, so we use solenoid. Okay, because 4 marks, so we write longer bit. Current is flow in circuit. So the solenoid is magnetized, become electromagnet. Then what happened? What happened? Iron also induce, become magnetized. Iron is attract towards solenoid. So you can say the force, the force is greater than the spring. So you can move forward. Then when the switch is open, oh, this one I need to tell you what is open and close. Close means switch on. Reopen means switch off. So you need to be careful this. Okay, because this one less mark already, so you can say solenoid and the iron is demagnetized. Then the spring pull the iron back to original position. That's all. Because the spring have force. Okay, this 4 step to demagnetize. So what is the mistake they make? This one cannot fully. Because question asks you whether can or not. So you say cannot. Cannot always demagnetize. Okay, which step are wrong? The step wrong are 3 and 4. Okay. In step 3, the current should be switched on. We cannot switch it off. We need to turn it on. Then in step 4, remove magnet slowly from the coil, long coil. Okay. So like this can be fully demagnetized. Because we need to make the magnetism inside the magnet not arranged. So we need to do this step. Inside magnet, inside have domain. So their domain will be in arrange. So this side will be the north, another side will be south. Okay, this one is the magnet arrangement of the domain. So when you demagnetize, the domain will be like this. They cancel each other's. This one normal matter. Domain not arranged. Long coil. This one long coil, we also call it solenoid. Then we put AC supply. Must AC supply. Why AC supply? Need to put a magnet inside. Let's say north south. But for the solenoid, in this question say long coil. Okay. The magnetic field keep changing. Okay, what I mean by keep changing? The polarity of the solenoid will change. Sometimes north, sometimes south. So the south and north keep change. Why? Because the current also keep change direction. Okay, because of this, your magnet, how to follow? Your magnet will confuse which one is north, which one is south. So the inside the domain will not in arrange. Then the north and south will disappear. Actually, not disappear. Actually, they are cancel out each other. Like resultant force, they cancel out each other. So north south will disappear. And always demagnetize. We need to remove the magnet out slowly. Then the direction will difference. So the able cancel out the magnetic field. The magnetic field can cancel out each other. Okay, and what is domain? Domain is arrangement of electron. So actually it's related to the electron. Okay, what is this? So call it the motion. Okay, this one is motor, this one motor. So which hand you need to use? Use Fleming left hand rules. Okay, then you see the current, how it flow. From the battery positive, go to negative like this. Okay, see inside the coil, where is the direction? Okay, when use left hands, you when use right hand. Left hands when have power supply. You also can think that is used for motor. A power supply also can be battery. Battery. So right hands don't have reverse one. Don't have power supply. Then for generator, I give you another example like this. Wire in between. Wire. Okay, want to use left hands or right hand? Don't know. Okay, because you need to see outside. If got like this, don't have power supply, so use right hand. Let's say if question give you power supply, so use left hands. Okay, so what I mean is you need to see the outside here. Got power supply or not? Got current supply or not? I go back to this motor. Yeah, this one is motor. Okay, try you use your left hands. Left, this one is left motor. If you're confused, I put the naming there. AB, wire AB. Where is the direction of AB? Current out of paper. We standardize, use AB. Okay, AB. So what is the force? Upwards. Then another side will be downwards. I mean the force. Okay, your thumb is force. First finger, north to south. Second finger, center finger, current. Because the motor are rotation, so this one is in clockwise direction. I give you some time to try this. Able to get clockwise or not? Clockwise. Turn your hand, turn. Current. I clear all first. Okay, I clear all. Okay, you see the battery, positive here. Current is flow from positive to negative, so it's flow like this. So AB is current is A to B. This is how we found the direction of current. So the current we need to depend on the battery. Clockwise direction. Okay, how is clockwise? Okay, you need to see where is your force first. AB is upwards, another side will be downwards. Because it's rotation, so it will rotate like this. So it will be clockwise, and our eyes is here. Front view. Our eyes always from the front view to observe. Don't say from the back. From the back will be anti-clockwise, of course. So from the front view, we will see clockwise. Rotate in the clockwise is step. Now we need to do the explanation. You can say it by using framing left-hand rules. Okay, so you can say that any motion. So we need to talk about the magnetic field, create a force. There have two magnetic field, which from magnet and electromagnet interact each other and produce force. Must mention two magnetic field and create this force. And then you can add it on. Add on the two forces is in opposite direction and create moment, the turning effect. So actually this one 4 marks already. The explanation. This one is clockwise. Because where is your pivot? Pivot is this one dotted line. The dashed line is your pivot. Because the coil is turning on the center, so the center is a pivot. Okay, you see magnetic field strength M. Then turning effect give T. Okay. So now the ampere is 2. Number of turn 3, 2, then M provided by T. Then give you the choices. We always compare with the first one. So you see current multiply 4 times. So your motor will turn 4 times faster. Just like this. After that is number of turn change. Double. So your turning will be double faster. Turning effect will be double. Magnetic field strength become half. So turning effect also will become half. This is the factor force or turning effect. The more the number of turns, the higher the turning effect. The more the current, the more the turning effect. The more stronger magnetic field, the more turning effect. Like this.